So today we're going to be writing the equation for a circle, and we are going to take a look at the standard form for the equation of the circle, and it gives us some information. Our center is going to be in this formula represented by h comma k, so that's like your x comma y coordinate, and the radius will have a length of r. So our standard form, we're going to have the formula x minus h quantity squared plus y minus k quantity squared equals r squared. And this should look similar to your distance formula since it's based off of that formula. That may help you remember the formula, how to plug some information in. Now, just like every time we write an equation of a line, we typically will see the x and a y in the formula. Same kind of thing here when we're looking at a circle. You're going to notice the x is going to stay x and the y is going to stay y, and the only other letters that we are repeating are the letters h and k, and the radius, which is r. So we're going to look at the problem on the side where it says write the equation of the circle shown below. So to our right, we have a picture, and I see this circle, and I'm seeing that it's telling us our center is located at 3, -2, and the only other thing we need to know is the radius length, the distance from the center to the edge of the circle. And looking at it graphically, I can see the radius has a length of 1. So anytime we're learning a new formula, I always think the more you write it, the faster it'll be if you want to memorize it. So the more you write it, the quicker you'll have it memorized. Here's our formula. We have the center located at 3, -2. So the center, remember, that's going in for your HK coordinates. So if I look at 3, -2, that's going to be my H, -2 is going to be my K value. So going over to the formula, we have x minus our x coordinate, our h coordinate, which is 3. Close that and square it. To that we're going to add y minus our k value, which is a -2. Close it, square it, and set that equal to your radius squared. So your radius has a length of 1. Now we do want to simplify this a little bit. So the first thing, we don't really have to do too much with our first parenthesis. Our first factor, we're going to leave it as x minus 3 squared. That's good. And our second one, we have minus a negative. So we do want to simplify that to be plus a +2. And then we do want to square out the radius. 1 squared is going to leave us with 1. So here is our equation of the circle, centered at 3, -2, and it has a radius of 1. Okay, we'll try another example. Same thing, I'm going to write the formula out first. So I have x minus h squared plus y minus k squared is equal to the radius squared. So they've given us a center for the circle at -6, 2. So again, -6 is the h value, 2 is the k value, and it has a radius of 5, so we know that that's going to be your r value. So I'm going to plug this in and try and simplify this all at once. So plugging this in, I have x, so minus a -6, so minus a negative we know is plus a +6 squared plus, we go to our y, I have y minus our k value, which is 2 squared. I'm going to plug in my radius. Our radius is 5, so if I square 5, I have 25. So that's going to be our equation of a circle centered at -6, 2 and has a radius of 5. We're now going to write an equation whose center is at 0, 0 and has a radius of 2. So x minus h squared plus y minus k squared equals your radius squared. So if we plug this in, I have x minus 0 squared plus y minus 0 squared and equals our radius squared. So if I square 2, that leaves us with 4. Now, you could leave it like this. You typically will not see x minus 0 or y minus 0. What you will typically see is that simplified. So x minus 0, well, that's just going to be x squared plus y squared equals 4. So it's kind of an important form to see. I see an x squared plus y squared, and it doesn't look like there's any coordinate located. Well, if there's no coordinate to represent that h and k, something you want to keep in mind then is that's telling you that the center is at 0, 0. Now this next question, we're almost going backwards. So it's asking us what is the center given this equation, and what is the radius given the equation. So looking at that equation, I know where we're going to find the center from. Those are going to be the coordinates listed with the x and the y. And looking at that, I've already seen, ooh, it just looks like x squared, and it doesn't look like there's any other number associated with that. So thinking about that previous example, that means then, well, the center's x coordinate must be at 0. And if I look at the y coordinate, well, the y coordinate must be located at 11. Keep in mind that formula that we have, if I were to look at the y section, notice where we're finding our k value. K value is going to be 11. Okay. Now the same thing for the radius. If I were to look over here at the radius, well, that looks like r squared is equal to 144, but I just want the radius, so I have to think, well, undo a square. So I'm going to introduce that square root on each side, and that's going to leave me with a radius of 12. Now something, again, keep in mind, anytime you take a square root of something, you will get 2 answers, but we're only focusing in on the positive one because we are trying to find the length of the radius. Okay, and then the last question we're going to take a look at is one that says we have a circle and it's centered at the origin. So that means if I'm thinking centered at the origin, my coordinate's 0, 0. And it goes through the point 0, 2. So here's my center. It goes through the point 0, 2. So that's telling me it looks like we have a radius here of 2. So graphically, I know that it should hit at all 4 of these points. So I have a circle, something like that. And it says determine whether or not the circle would go through the point at 1, square root of 3. So the first thing we want to do is, again, write that equation. Let's make that equation. So I'm thinking, okay, x minus 0 squared, plugging in our center point, plus y minus 0 squared equals our radius squared. And if the radius is 2 and we square that, well, 2 squared, we're going to have 4. So that's representing that circle that we have centered at the origin going through the point 0, 2. I want to determine if it's actually hitting the coordinate 1, square root of 3. So just like we did with equations of lines, we would say, does the point satisfy the equation? In other words, if I were to plug that into the formula, would the left side of the equation balance out to the right side? So we're going to try. So in place of x, we're going to replace it with the coordinate, and I have 1. And in place of the y, I'm going to replace it with our coordinate, which is located at the square root of 3. And now we're saying, okay, if it is on the equation, the left side should equal the right side. So this is kind of like a question. I want to see, is this actually going to work here? And I am going to go back and change this. So now we are going to simplify and see, does this work? So 1 minus 0. I'm going to simplify that. That's 1. Still need to square it. Square root of 3 minus 0. Well, that's going to give us the square root of 3. And I still have to square it. And then I'm going to set that equal to 4. And again, I'm still trying to figure out, are those two things equal? Okay, so if I have 1 and I square it, I get a value of 1. Square root of 3 squared, well, if I square a square root, they undo each other. They're inverse operations. I'm left with 3. And again, I'm trying to see, does that equal 4? So looking at this equation, I have 1 plus 3. So my left side equals 4. The right side equals 4. So that's telling us yes. Yes, it would go through that circle. It satisfies the equation. The point 1, square root of 3 is in fact on the circle. Hope you found this helpful. Don't forget to like and subscribe.